In the previous example, we had performed what was called a one-sided or a right-tailed hypothesis test. Now, why is it called a right-tailed test? Well, it has very much to do with the calculation we perform. So when we go through and we form the null and alternative hypotheses, the direction of the alternative tells us which tail to perform our calculation, and it gives us a sense of direction, and it gives us more certainty as to where we should be checking our probability result to get the p-value. Now, you can do the same thing for a left-tailed test. So if your alternative hypothesis points in the other direction, you've got sort of insider knowledge and more certainty about which way you should be checking or biasing your results in some way. Now, there is a final option, something called a two-tailed test. Now, a two-tailed test is the most uncertain. Here you are unsure of what direction to choose. And so there is more uncertainty. And that increased uncertainty is going to get reflected in our calculation. So we'll take a look at the other pretzel example on the sheet. And here, the null hypothesis is the claim that there is no problem with the machine. So there is no change in the actual value. They claim to make bags of pretzels with 454 grams in each bag. Now, if we are interested in the alternative, is there a problem with the machine? The problem with the machine is unclear. Which direction should we be going in? And so the alternative hypothesis is simply mu is not 454 grams. So when we take all the possible values for mu, the null hypothesis is the single outcome here at 450, whereas the alternative is everything else. So this is going to be what we call a two-sided alternative. So we are going to take a look at both sides of the tail in some way of thinking. So evidence comes from the sample, and the sample evidence says, okay, you took a sample of size 25. The boss said, go check to make sure if the machines are working. So you do what she says, and you go and you take a look, and you find a sample with a mass of 454 grams on average. So you took 25 bags, and the sample standard deviation is 7.8 grams. So the null hypothesis now talks to the problem by saying, okay, whatever the sampling distribution is here for X, for all of the averages, I think that the center should be at 454. Now, you took a sample and you found a sample average of 450. Now, because this is to the left of the center, we are going to end up having to calculate a left area. But the uncertainty of the two-sidedness will come into play in just a moment. So we will standardize this as a standard t variable problem. Once again, the null hypothesis talks to the problem by setting the middle. When we standardize this, we will turn the problem into a t distribution, so it's centered at 0, as all t distributions are. And the value that we calculate ends up being about negative 2.56. That's what the sample average of 450 turns into. So what is the chance of getting an X bar of 450 when I take a sample of size 25? Now, for a two-sided alternative, we are more uncertain. And so the idea is that because it's a two-tailed test, a two-sided, we are going to multiply the tail area by 2. We are going to say that the p-value in this problem is going to be the probability that t will be less than or equal to negative 2.56 in a t24 distribution. And then we're going to multiply it by 2. The multiplication by 2 is there to represent the greater degree of uncertainty that we have. We don't know which direction we should be going in. All that we know is that it's broken. So we have to account in some way for both of them. So we are doubling the probability of seeing this result. And that makes it harder to reject a null hypothesis. So when we go through, we can calculate this as we normally would. And all you do is you can use the PT function. And so in R, this would be 2 times PT, negative 2.56, and a degree of freedom of 24. And you should get 0.0170. And that's with the doubling. So now you have to make a decision. Do I have a rare sample here, or do I have the wrong mu naught? Is the claim wrong? Because my p-value here is very small, I am choosing to reject the null. I will choose to reject the null hypothesis since the p-value is about 0.017. Again, the ballpark is 5%, but basically I can reject this at the 2% level. At a significance level of 2%, I could reject this, but my boss is being very stringent. She says, no, if you find anything with a significance level less than 1%, you can't reject it. So I cannot reject at an alpha 1% significance level. And in some way it's arbitrary. You have to decide upon this ahead of time what the level will be. But in this case, if I said 1% significance, I cannot reject. So the mechanics of a two-sided test are not that much different. You have to remember to multiply by 2, and that reflects a greater uncertainty.